Welcome back. This is the second lesson recording for April 23rd, IM1. So now we're up to card number 3 of Desmos. So it's asking you which image is the original. How can you tell which is the original? How can you tell which is after transformation? It's with the notation of each of the points, right? In this case, this point is called E, while as this point is called E prime. So this tells me the original is the orange, and after the transformation is the purple. So the original is the orange. And I'm going to submit. Great. And which of the following describes our translation? Okay, so look at the point here. How do I do that? E corresponds to E prime. These two match up. Okay, so then you need to be thinking about how did the point E become E prime? So it went down and then went to the left, right? So we need to be counting how many did it go down by? 1, 2, 3, 4. It went down by 4, and we can write that as -4 because going down is becoming more negative on the y-axis, and going to the left by 2 means it's becoming more negative on the x-axis. So we can say it's going to the left or -2. Okay, so or going down by 4 or left by 2. So move left by 2 units and down by 4 units. So that's going to be my correct choice. Okay, image moved left 2 units and down 4 units. Which of the following rules describes the translation? Going left means it's becoming more negative. So here we went left, went down 1, 2, 3, 4. So down y went down by 4, then to the left by 2, so it's -2 here. So x coordinate, the horizontal position changed by subtracting 2, the, the, the new point, the old point, and the new point. The old point went to the left by 2, so or subtract by 2, so that's the x coordinate, x -2, and the y, it went down by 4, it's going to be this. Okay, so that's how you would write that translation. It went to the left, the x coordinate, the horizontal position moved towards the left, which is a negative direction by 2. The vertical position, the y position, went down, which is a negative direction by 4. Going back to our slides, so transformation rules tells us how to compute the new location using the old location. So if, for example, if I have x comma y in parentheses, that means whatever the number on and this is what we call arrow notation, where it tells you this is the original and this is the coordinate of the transform. Okay, so we started with original x, and the x, what happened to the x? X got added by 5. Then y here got subtracted by 7. So what does that mean? X plus 5 means the coordinate of the new coordinate is the original x coordinate, that's the x, original x, plus 5. The new coordinate, new x coordinate is the original x coordinate plus 5. What about the y coordinate? This tells me the y coordinate. The new y coordinate after the transformation is the original y, that's the same y coordinate minus 7. So whatever the coordinate, whatever the number was, we subtracted that by 7 for y, and whatever the x was, we added 5 to it. So when you have original to transformation notation like this, You are adding and subtracting operations are part of translation rule. This rule represents translate right by 5. That means add x plus the x coordinate tells you the horizontal position. So it moves left and right, just the way axis goes horizontally. So x moved right by 5 because when you move to the right, it becomes more positive. And then it went down by 7 because when you subtract, that means we are becoming more negative, and that's down. All right, so let's try using translation rule. Okay, so what we can do is we can write the coordinates of each of the points, the corners of this polygon. So let's do just that. Okay, so let's start with one corner. So we have negative 9, 6. Notice that I need to put parentheses. If I don't put parentheses, that's not the x and y coordinate. And then negative 6, comma 8, and negative 1, comma 8, and negative 4, comma 3. I literally just went and copied all the points, all the coordinates that is written there, because that is the coordinate of each of the corners. Okay, after translation, it says x plus 5. Whatever the original x was, we added 5 to it. Okay, so what was the original? What was the original? It was negative 9. Then to that, we added 5 to it. Okay, so that was original, and then we added 5 to it. That's what x plus 5 is implying. And what about to y? What is going on to y? Y is whatever the y value was, which was 6. And then we're going to subtract 7. Okay? And then what do you get when you do this? This is really same as negative 9 plus 5 is negative 4, comma. 6 minus 7 is negative 1. So the new coordinate after translation is going to be negative 4, comma, negative 1. So what used to be negative 6, negative 9, comma 6 became negative 4, negative 1. It's this point right there. Okay, so this point just became this point. Okay, all right, then let's try the next point. Okay, so negative 6, 8. It's this point here. Now, if I have negative 6, and it says whatever the x value is, we're going to add 5 to it. The old x value was negative 6, and we're going to add 5 to it. Whatever the y was, we're going to subtract 7 from it. And so the new coordinate is negative 6 plus 5 is negative 1. 8 minus 7 is 1. So the new point for this that matches up with this is going to be negative 1, comma 1 is right here. Right? Then let's keep doing it with other points. Okay, let's do this point here. That's negative 1 and 8. Okay, so get your negative, the x coordinate, the odd negative 1, odd coordinate is negative 1, and then to that you're going to add 5 to the x, all the x value, and get your y value, which was 8, and then we're going to subtract 7 from it because that's what the rule is telling us to do. Okay, and so you're basically doing the same thing here, right? All the numbers, for the x's, we're adding 5, 5, 5 here, or the y's, we're subtracting 7 from each of the number. When I do that, negative 1 plus 5 is 4. 8 minus 7 is 1. So it's going to be 4, comma 1. Where is 4, comma 1? 4, comma 1 is right here. All right, and then finally, let's do the last one. Okay, last one is this point here. -4 comma 3. So we get my original -4, and to that we are going to be adding 5 and get your original y, and to that we are going to be subtracting 7. That's what our rule is telling us to do. And so each of the point we're consistently adding 5 to the x as we're taught, and for y we're consistently subtracting 7 from the whatever the all value was. -4 plus 5 is going to be 1. 3 minus 7 is -4. Okay, so it's going to be 1 comma -4. So x is 1 comma -4 is right here. Okay, now that I have plotted it, I can join using a straight line. Well, I'm just going to join. Okay, and that's my shape. Okay, so this is the original. This is my after translation. Notice that the shape is the same. The orientation is the same. The only thing that has changed is its position. So now you're going to be working on card number 6 to 13 of Desmos. Okay, here we go. What is the rule for these translations? Okay, to do this, you just find the corresponding point. First, you figure out which is the odd, which is the new. Well, this is C and C prime, so this is my original. This is my new. Okay, so what's going on between C and C prime? How is it changing? Okay, to figure out how it is changing, you can count. We say, okay, it is changing 1, 2, 3, 4, 5. Vertically, it's going down by 5, so we can say -5. What about horizontally? It's moving 1, 2, 3, 4, 5, 6. So it's moving to the right. Moving to the right on the x-axis, when you move towards the x right, it is adding. The numbers are becoming bigger. So it's going to be adding 6 to x. Okay, the horizontal is the x value, right? Just the x-axis is the horizontal, whereas the vertical is the y value. So y is being subtracted by 5, x is being added by 6. So let's look for y being subtracted 5, x being added by 6. So it's this one. Card number 7. Okay, in this table, calculate the new coordinate for the translation rule. This time we're not given the translated images, but we are given the rule. Okay, so what does that mean? Okay, we can do it two different ways. Let's start by doing it using this notation. So when you look at this point right here, the coordinate is going to be 1, 1. That's 1, 1 right there. So x gets added by 5. So x plus 5 is going to be 1 plus 5 is going to be 6. This is going to be 6 here. And then y gets added by 3. 1 plus 3 is going to be 4. So if I was to draw this, it will be 6 comma 4. 6, well, actually, let's just create the table. Okay, 4 gets added by 5. 4. So this is going to be 4. Well, the original is 3, and then we're going to add 5 to it. So that's going to be 8. Okay, and we can do all the vertical ones. And we know the original is 3 here. And again, with the x's, we are going to be adding 5 again. And whatever the all the x was, we're going to add 5 to it, 7. And whatever all the x was, we're going to add 5 to it, that's 7. Whatever the odd was, we're going to add 5 to it, so that's going to be 6. And then we are going to be doing the same thing with the y. Whatever the odd y was, we are going to add 3, which is 4. And 2 is my original, plus 3 is 5. Okay, I'm just going to copy down the values here. And then I am going to add 3 to it, for each of the coordinate. That's going to give me 5 and 7 and 7. When I submit, that's what I get.